This is Mr. Carr, and today we're going to be talking about 4.3 Day 2. This is going to be another application of our slope-intercept form. We're going to be focusing on the ideas of parallel and perpendicular lines. So let's look at this scenario that creates one of those two. Jason and Scott plan on biking to the center of town to get ice cream at the convenience store. Since Scott had to put air in his tires, Jason was able to get 1 mile ahead of Scott before Scott left the house. Both bikers rode at a speed of 15 miles per hour. So let's first write an equation in the form y equals mx plus b that represents Jason's trip. Well, Jason was able to get 1 mile ahead. So Jason is going to start with 1 mile. His rate of change is 15 miles per hour. So I'm going to write y equals 15x plus 1. So we have our realistic slope is 15 miles per hour, and then his y-intercept is going to be 1. That's where he starts at. Scott started later, so he doesn't get a head start. He's also going 15 miles per hour, so he's going to have 15x, but then he doesn't get a head start, so he's going to start at 0. So we're looking at these two bikers. Will they meet before they reach the store? So look at that idea. If they are both traveling at the same speed of 15 miles per hour, will Scott ever catch up to Jason? No. They're going the same speed and Jason has a head start. There is no way he's going to be able to catch it. So I want you to try to think about, make a quick prediction, what you think the graph is going to look like for these two scenarios. So let's try these. These are going to be representing a similar idea. So y equals 3x plus 4, 3x minus 4, and 3x. I'm going to do 3x plus 4 in blue here. So my y-intercept is 4. I'm going to go up to 1, 2, 3. I'm going to go up here to positive 4 for my y-intercept. For my slope, I can go 1, 2, 3 to the right 1, or I can go down 3 to the left 1. Okay, so there's my first graph. The next one I'm going to do is going to be in green. So 3x minus 4. So I'm going to start at a negative 4 in the y-intercept. So that's down here. And go up 1, 2, 3 to the right 1. And down 3 to the left 1. And here's my second equation. Okay, my third equation is going to be written red. I'm going to do y equals 3x. So that has no y-intercept. But the y-intercept, that means it's going to be 0. So I'm going to do the same thing. Up 3 to the right 1. Down 3 to the left 1. And then connect those dots. Hopefully you're noticing, if I wrote them a little bit better, you would see that the nice straight lines, hopefully you would see that they are not going to cross. So when you notice these, they should never intersect. If lines will never intersect, they create parallel lines. And you notice in all three cases they had the same slope. The slope was 3. So parallel lines have to have the same slope. Now, just out of curiosity, if one person had the same exact thing on top of another, well, that would make them not parallel. So we'll talk about that in a future unit. So I'm going to add to the fact that parallel lines have to have the same slope but different y-intercepts. So that's what it takes to be parallel. Next scenario we're going to look at is these two equations. I'm going to do the same thing. I'll do 2x plus 1 in blue and negative 1/2 x minus 1 in green. So 2x plus 1, I'm going to start at a positive 1. Go up 2 to the right 1. And I'm going to just do a lot of dots to help make it graph a little easier for me. And then down to left 1 and so on. So there's my first graph. Okay. Negative 1/2 x minus 1. So it's going to go down 1. I can go up to the right, or up 1 to the right 2. Sorry, no it's not. I would go up 1, left 2. Up 1, left 2, and so on. And I could go down and to the right. Okay, so when I make these lines, hopefully you've seen something that looks like that in the past. It's a little tough to see on here, but these lines are crossing. They're forming a nice right angle. I'm going to notate that with this box. That is a right angle. So when two lines cross and form a right angle, they're a special thing. That's called perpendicular lines. Well, take a look at how these slopes compare to our parallel lines. Is there anything you notice about -1/2 and a +2? Make a quick prediction before we move on to the next part. So on the same set of axes, let's try these two lines. So we have -2/3 x plus 4 and 3/2 x minus 3. We'll do -2/3 x plus 4 up here and a -2/3. So we're going to go down 2 to the right, 3. Down 2 to the right, 3. And I can go up to the left 3 and so on. So there's my first equation. Ooh, let's try that line again. That was bad. Sometimes Mr. Carr makes pretty poor mistakes there. Okay, and also just realized made another poor mistake in the sense that my last point was up 2, but it was not to the left 3. So right there, that's better. Okay, now that I have that line, I'm going to go ahead and do 3/2 x minus 3. So that's 1, 2, 3 down. We go up 3 to the right, 2. Up 3 to the right, 2. And we can see how it crosses right there. Does this look like the previous graph? I think so. I think we're pretty safe to say that is another perpendicular pair of lines. So again, look at those slopes. I have -2/3 and a +3/2. Thinking about that for a second? Here's the big key. Perpendicular lines have slopes that are opposite reciprocals of each other. So for example, if I look at the opposite reciprocal of 6, first thing I want to do is treat it like it's a fraction, 6/1. The reciprocal is me flipping it to 1/6 like this. And then when I say opposite, I mean the opposite sign. It's a negative instead of positive. And if I start with a negative slope, I'm going to finish with a positive slope for my opposite reciprocal. So when I look at number 5, all of these have opposite reciprocals. So I have -4/1, my perpendicular slope. And that's what this symbol means. It means perpendicular. So my perpendicular slope is going to be a +1/4. My perpendicular slope for B is going to be a -2/5. And my perpendicular slope for C is going to be a +7/3. D is a little bit interesting. If I have a slope of 0, think about that for what kind of a line I have. My opposite reciprocal, I can try, let's just do 0/1. That would be a -1/0. Well, that's not possible. That's undefined. So what I'm showing with D is that any horizontal line and any vertical line are going to be perpendicular. Hopefully that makes sense. So right here we have 4 equations. 1, 2, 3, and 4. And I just want to analyze which ones are parallel and perpendicular. So when looking at the parallel idea, we have equations 1 and 4. They both have a slope of -1/5. And also they have different y-intercepts. We have 7 versus 8. That leaves us 2 and 3 are going to be our perpendicular slopes. So we have it's 1/5 compared to -5/1. So that's our slopes there. That's what creates our perpendicular lines. Well, we can further apply this when looking for new lines, new equations of other lines. So we're going to apply the ideas of parallel and perpendicular, and I'm going to go over number 7, A and C, and number 8, A and C. So write the equation of a line that is parallel to the given line and passing through the given point. So thinking back to where we did before when we made our equations of lines, I only need 2 things to write the equation of a line. I need the slope and I need the y-intercept. So for this case, you are given the slopes. It's just not being told directly. When I look at part A, my slope is 4. So that means my parallel slope is also going to be 4. It's going to be 4x plus my y-intercept of B. Well, when I look at my equation, what I've done in the past is I could plug in an x and a y. However, this is actually my b value. When I say the point or the line passes through the point 0, -3, that means my b is equal to -3. So my equation is going to look like this, 4x minus 3. Part C is a little bit trickier. I'm not giving you the y-intercept with that point, but we're still going to apply the same idea. The two things I need to write the equation of a line, I need the slope and I need a y-intercept. So I'm going to start with y equals -5/6 x plus b. So if I want to find the value of b, I could plug in 12 and 10 as my x and y values. By doing that, I've turned an equation with 3 variables down to 1 variable. So 10 is equal to a -5/6 times 12 plus b. So multiplying with my fractions, I'm going to make that 12/1. I can actually cancel 6 and 12 out, so I leave that as 1, and that's going to be a 2. So 10 is equal to a -5 times 2 is a -10 plus b. Add 10 to both sides, and then 20 is equal to b. So here's my new equation. It is going to be y equals -5/6 x plus 20. Again, the key part for these types of problems, you have to identify the parallel slope, which is the same as the given line. Then you have to plug in the point that's given, that's going to be on the new line, and that tells us our new y-intercept. Number 8, we're going to do very similar ideas, but now we're going to be focusing on lines that are perpendicular to the given line. So if we remember what we just covered, I'm actually going to start with C because that one's a little bit easier. So from what we just covered, perpendicular slope is going to be the opposite reciprocal. So my new equation is going to look like y equals -7x plus b. Well, looking at my new point here, 0, -6, just like my first example here, that is my b value. B is equal to a -6 because that's the y-intercept. So I'm going to just rewrite this equation, -7x minus 6. And I'm done. This line is perpendicular to the original because of its opposite reciprocal, and it has its own y-intercept of -6. When looking at A now, I'm going to go to this one. Same idea as my part C from earlier. 8, -2 is not the y-intercept, but I can use that point to find the y-intercept. So first thing I need to identify, that slope to be perpendicular is going to be a positive 3/4. So my new equation is going to look like this. It's going to be y equals 3/4x plus b. I have an x and a y value right here, so I'm going to plug those in. So -2 is equal to 3/4 times 8/1 plus b. 4 cancels to 1, 8 cancels to 2, so I have -2 is equal to 3 times 2 is 6 plus b. I'll subtract 6 to both sides so that I get a b value of -8. So my full equation is going to be y equals 3/4x minus 8. The examples I skipped over are going to be for you to finish on your own. So quick recap, that is going to be wrapping up 4.3 day 2. So what we are looking at is the idea that to create parallel and perpendicular lines, parallel lines have to have the same slope but different y-intercepts. The perpendicular lines have to have opposite reciprocals. So that's going to be taking your fraction of your slope and flipping it, and then doing the opposite sign, either positive to negative, negative to positive. We can use those to apply them to new lines by comparing when do they have the same slope and when do they have perpendicular slopes.